It's recording. New. Yeah, no, that would be just a short assessment. Our assignment, I would say, a worksheet for you. That's a worksheet actually. I used to make a worksheet on this specific topic. I have my worksheets for each topic of which I used to provide my students. So once I'll upload that on your portal, so you can download it to try to solve the questions from there, right? So
Mm-hmm.
then you can re-upload that again for me. I will just evaluate because there's a scorecard that from their side they have to record your progress as well. Okay.
Mm-hmm.
And what was this topic that we have discussed yesterday as far as chemistry is concerned, Filza?
Yeah.
What was that? Chemistry
What
topic. So,
chemistry topic we did
mm,
electronegativity. We also did one more thing.
mhm.
Intermolecular forces.
Intermolecular forces. Yeah. Okay. Just give me a moment, please. As we were talking about, like, just to recall the concepts, as you said already. So,
Mm-hmm.
I think we had talked about the physical atoms, amount of substance, acid. No, no, this is not what we have covered. Periodic table and energy, I think. Reaction rates, chemical equilibrium, physical chemistry, and transition elements. Can we start to talk about the periodic table and energy? Are the periodic table itself, like the periodicity, or the halogens, enthalpy change, reaction rates, chemical equilibrium? What do you think
Sure.
about? Or if you want any specific topics, we'll go for that. Otherwise, this is what, because we are revising things from the AS level. I mean your year. I mean, sorry, your year 11. So as per Alberta curriculum, so we can also talk about the periodic table as well. For example, there's a topic like periodicity, ionization, energy, structure, and physical properties, right? As just we can talk about the group two elements and the compounds. Similar with halogens, the use of chlorine, qualitative analysis. This is what we can cover here, right?
Yeah.
So, hmm. So periodicity. I'm hoping. Copy. It's not getting periodicity. Okay, I just need to write it here. Periodicity. Can you say it, periodicity?
Periodicity for what?
Yeah, we'll talk about this. This is the topic that we need to start with, right? So it's actually the structure of the periodic table that we have to talk about. That's that's a periodicity, like where you have to talk about the periodic table. It's like different, its overall, its distribution, and its properties, or the trends of some properties that we can talk about. The structure of periodic table, as you know, the periodic table is a list of all known elements arranged in order of increasing atomic number from 1 to 118. Okay,
Mm-hmm.
so the periodic table is what? It's a list of all known elements arranged in order of increasing number. Their order of arrangement is increasing atomic number from 1 to 18. Okay?
Okay.
So in addition to this, um, elements are arranged so that, like I would say, atoms with the same number of shells are placed together, and atoms with similar electronic configuration in the outer shell are also placed together, right? So
Mm-hmm.
again, two things. Those elements which are arranged in a way like they have the same number of shells, they are placed together. And those elements which have the same electronic configuration in the outermost shell, they are placed together. So how this is achieved? So you know the elements are arranged in rows and columns, right?
Yeah.
So the elements with one shell are placed in the first row, like hydrogen and helium. Okay.
Mm-hmm.
So elements with two shells are placed in the second row, right? That's from lithium to neon. And it's so on. Like one shell, that's in first row, two shells in second row, three shells in third row. So this is going on. This is the normal arrangement, right? So a row of elements thus arranged is called a period, right? So the arrangement of elements in row is called period. Okay. So
Mm-hmm.
so the period number, and actually small n, is the outer energy level, I would say, and that's actually occupied by electrons. Definitely, the periodic number is the outer energy level, which that's occupied by electrons. We'll talk about this as well. So in addition, the elements are aligned vertically in columns with other elements in different rows. On what basis? So base was like if they share a similar outer electronic configuration. So the outer electrons are known as valence electrons. Okay. So the structure of the periodic table is what? Periodic table is what? It's a list of known elements that's arranged, I mean, in increasing atomic number order. That's from 1 to 118. 118 I mean elements are placed, are present in the periodic table, right? So then we have divided that periodic table into rows and into columns, or into, I would say, into periods, and the second, I would that's actually, we can say we have just placed them into columns,
Okay.
right? So
Mm-hmm.
elements elements with one shell are placed in the first row and elements with two shells are placed in the second row. So the row of elements is called period. What's that called?
Period.
Yeah. The period number is the outer energy level. Most of the period number is like what is the number of electrons in the outermost shell. We'll talk about it. So in addition, the second thing is the elements are aligned vertically as well in groups with other elements in different rows. And that is just based on because they share, I would say, the similar outer shell electronic configuration.
Mm-hmm.
Getting?
Yes.
So the outer electrons are known as the valence electrons. The outer electrons are known as valence electrons.
Valence electrons.
Yes. So the column of the elements that's arranged is called a group. So I hope you know you're getting like what is periodic table itself? What do you mean by period? And what do you mean by group? Okay.
Group is if they're metal or
hmm I mean,
that kind of stuff.
yes, I would say like it's aligned vertically, like in groups, what we always say, as we have just the column of the elements. It's actually the column of the elements.
Column of the elements.
Yes,
Okay.
I mean the elements are arranged in column form. That's what we call group. And what is the basis of that arrangement? This is what I have already explained. Like elements are aligned vertically with other elements in different rows just because they share a similar outer shell electronic configuration. For example, if one element has 5 electrons in its outermost shell, the second would have the same, the third would have the same. So they have the same number of same number of electrons in outermost shell. Or their total number of the shells are same, quite there. So if they have the same number of shells, it means like they are going to have the same sort of number of electronic configuration there. So this is the base for the elements to arrange them in groups. In periods, what's the criteria? That's quite simple. We talked about it. Like we placed, I would say, elements are arranged in rows and columns based on, I've already told you the elements with one shell are placed in first row. That's horizontal. Those,
Horizontal. Okay.
right? So elements, one shell are placed in first row, two shells, second row. It means like all the elements of the same period, they have the same number of shells, right?
Mm-hmm.
However, elements of the same group from top to bottom, they have the same electronic configuration. That's the basis of its arrangement. Okay. So this
Mm-hmm.
is what we should understand. For example, I'm just putting a periodic table in front of you so that you may have the better idea. So like this is for you to understand. Filza, like, mm, look at this, please. Here it is. This is periodic table. You can see here, like this is what? Groups. And where are periods which are going horizontally like this? These are
Yeah.
periods, right? So, like all of these lithium, beryllium, boron, carbon, nitrogen, so they have the same number of shells. However, if we are coming down from top to bottom, although they are belonging from different periods, but they have the same electronic configuration. That's a bit similar, right? So
Yeah.
this is how we have divided the periodic table of the elements, known elements, into periods and groups. And we have just established the basis for it. And those bases I have already told you, like if they have the same electronic configuration, we place them in the in groups, I would say. And
Mm-hmm.
and those elements which they have the same number of shells, so they are placed in rows, right? First row,
Mm-hmm.
those elements which are present in the first row, they have first shell. I mean, they have one shell. If they have two, so two shells, three shells, four shells. So this is how we have arranged them in the periodic table. This is an overall idea that we should know. Like, let's talk about a bit more. For instance, I would say now the periodic table is in front of you. You can see the electronic configuration of hydrogen and helium are unusual. Why? Because they don't fit the comfortability. I mean, they don't fit comfortably into any of the groups. That's the thing. They are, you can see, so because, and that's, they are thus allocated a group based on similarities in physical and chemical properties with other members of the group. You can see like both of these elements, hydrogen and helium, although they are not, they don't have that basis, but we have already discussed about the periods and groups, right? But there was no other space, there was no other any specific location where we can place the hydrogen and helium. So that's why what scientists or the chemists, what they have done, they actually arrange this hydrogen and helium in the periodic table based on similarities in physical and chemical properties with other members of the group. So they are not arranged in the group just based on electronic configuration as we have the general principle. I don't know you're getting this point or no, it would be justified from your response. What I'm seeing right now, there's exceptional case of hydrogen, filza, and helium. What
Yeah.
what they are saying, the both elements are not suitable for the location that we have already placed them, because they have you know, as you know, hydrogen has only one electron, this helium has only two electrons. So they are not in similar situation like with other groups, as we have divided all of the groups based on electronic configuration. So their electronic configuration is quite different from other group members. So that's why scientists, what they have done, they have taken their physical and chemical properties.
Okay. Okay.
Just based on these two types of properties, physical properties, chemical properties, we have just placed hydrogen and helium in the group, in this group where they are right now. Okay,
Mm-hmm.
then after we can talk about like mm, he- helium is placed in group zero, I would say, on the basis, but hydrogen doesn't behave like any other elements as so is placed in the group of its own. It has its own group. You can see here. Now here's a helium and here's a hydrogen. Hydrogen has its own group. So this is in group O. This one is group O. Here it is. Can you see here on the board where is
Yeah.
helium and where is hydrogen? Hydrogen has, I mean, it's quite dissimilar. It has no similarity with other elements, so that's why it has its own group like this. And in second case, you can see helium is present in O group, right? That's the
Mm-hmm.
difference, Filsa. So the physical and chemical properties of elements in the periodic table show clear pattern related to the position of each elements in the group table. Elements in the same group show similar properties, and properties change gradually as you go across the period. That's important thing. The physical and chemical properties of elements in the periodic table show clear patterns. That's not random or haphazard. That has a clear pattern. If something is increasing, so it's increasing gradually. If something is decreasing, so it's decreasing gradually. So
Okay.
there is a clear pattern of any of the properties that you want to talk, like any of physical and chemical property. So elements in the same group show similar properties. Properties change gradually as you go across the period. All right. So
Mm-hmm.
as atomic number increases, the properties of elements show trends that repeat themselves in each period of the periodic table. This trend are known as periodic trend. And the study of these trends is known as periodicity.
Okay.
Getting?
Yeah.
Like, if I can put for you here, like on this table. Yeah, you can look there because those trends I have already told you, like the physical and chemical properties of elements in the
Mm-hmm.
groups and periods, they have a very clear pattern. Very clear
Mm-hmm.
pattern means like something is increasing, so that's gradual increase. Something is decreasing, gradual decrease. So this is what we call the trend. And these trends are known as periodic trends. And the study of these trends is known as periodicity. And we'll take some examples as well in order to understand what is periodicity in that case and what the periodic trend that we are going to talk about. For instance, like in this case, if I would say periodic trends in electronic configuration, like I can show you here pattern for the periodic trends in electronic configuration. And for that purpose, I'm just going to paste diagram for it so that you may understand. The periodic trends in electronic configuration. This is what we need to talk about. So here's a diagram that I want to show you. So Filza,
Mm-hmm.
it's here. Can you please look at this? Is this visible to you?
Yes, it is.
So here is S block here, P block, D block. So you can see here, like just check the electronic configuration trend. So it's not random. Like you can see here in this case, like 2S, 3S, 4S, 5S, 6S, 7S, 3D, 4D, 5D, 2B, 3B, 4B, 5B, 6B. So F block, 4F, 5F. So this is the periodic trends in electronic configuration. In S block, in D block, P block, F block. What are these blocks? These blocks are actually showing what is the subshells that you have, where you are ending the last shell of your element. So this is the electronic configuration: 2S, 3S, 4S, 5S, 6S, 7S. So what it shows, Filza.
That the more it decreases, the more it increases.
Hmm. No, in other words, like Filza, I'm just talking about in a sense, like what is the periodic trend? Is that not a gradual increase or the gradual process or I would say the pattern? Can you see the pattern or the sequence of this change that we can see in the groups and the periods?
Yeah.
All right. So the periodic trends in electronic configuration is shown here. So it means this is the trend study, the study of these periodic trends called what? Called
Mhm.
periodicity.
Um, okay.
Periodicity. Periodicity
Periodicity.
is just the study of the periodic trends in the periodic table. I've just given you an example of electronic configuration, electronegativity, electron affinity. So any other property that that's a chemical or physical property that you are going to study here. So that would be based on a proper, regular, gradual trend. Getting?
Yes.
Any question in your mind, Filza?
Nope.
No question?
Nope.
Okay. So then after, let's talk about the like elements belong to one of four main blocks. You know, the S block, the P block, the D block, and F block. I can explain it. The S block elements are all those with only S electrons in the outer shell. And P block elements are all those with at least one P electron in the outermost shell. And D block is the similar way, and F block is there. So the trends across the period, that's what we can talk about. Each period starts with an electron in a new highest energy shell. Each period. Across period 2, the 2s subshell fills with 2 electrons, followed
Mhm.
by the 2p subshell with 6 electrons. Across period 3, the same pattern of filling is repeated for the 3s and 3p subshells. So for each period, the S and P subshells are filled in the same way, a periodic trend. This is what we can talk about. All right. So the point is, we have a regular trend of any of the changes in the periodic table. I'm just going to give you an example of ionization energy.
State of energy.
Hmm. Ionization energy, yeah. It's one of the physical property that I'm taking right now in order to understand its trend here.
Okay.
So if I would say, what's ionization energy?
Mm,
Energy, I'm just starting with you. Just a moment, please. Miss Filza,
yeah.
look at this, please. Ionization energy. And let me just put one thing for you. Energy required to remove 1 mole of electrons from 1 mole of atoms of an element in the gaseous state to form 1 mole of gaseous ions. I'm just starting with you the first ionization energy, and
Mhm.
then we'll talk about it. Like, for example, I can show you here. Let me write something. Yes, it is already written. Look at this. This is the first ionization energy. This is first. I just removed one thing from here. FIR. First ionization energy. And what's that? Energy required to remove 1 mole of electrons from 1 mole of atoms of an element in the gaseous state to form 1 mole of gaseous ions. I mean, it's just, I would say, Pilza, amount of
Mm-hmm.
energy which is required to remove the outermost electron. A very simple definition. The amount of energy which is required to remove one electron or any of the electrons from the outermost shell. So just by having that in mind, now we are talking about the first ionization energy. It's a definition of the first ionization energy. It means like what you are going to do, you are removing the first electron from the outermost shell. So the first ionization energy is the energy required to remove 1 mole of electrons from 1 mole of atoms of an element in the gaseous state to form 1 mole of gaseous ions. Don't just confuse with the 1 mole, 1 mole. You can remove this from here as well. 1 mole of
Oh,
electrons from the 1 mole of atoms of an element in the gaseous state to form 1 mole of gaseous ions. Definitely, when you are removing electron from there, so that's something like you are converting that into ions in the
mm-hmm.
gaseous state. If you're removing electron from there, so they are anions and cations there. So that sort of thing like we should understand. Got it? Got it.
Yes.
Okay. So the first ionization energy of sodium, I can just give you an example of it. And then after we'll talk about the factors affecting the ionization energy. And we'll talk about the atomic radius, nuclear charge, electron shielding. So there's all different sort of trends. So I'm talking about the I just want how I can take it. That's an example for you, Ilza. The first ionization energy of sodium is like I just put it down. The first ionization energy that you will have here is is I'll show you like what do you mean by this positive and negative. 496 kilojoule per mole. It's positive. What do you mean by this positive? Oh, yes. We'll see somewhere like if we are talking about the second ionization energy, the third ionization energy, so somewhere you'll see the sign would be changed. In this case, you can see here, this minus sign is showing you like right now it's a positive, not negative. So this positive sign is showing you the amount of energy which is required to remove the first electron of the sodium. And it's about 496 kilojoule per mole. If you'll provide 496 kilojoule per mole to sodium, then only you will be able to remove electron from there, from the outermost shell. That is first ionization energy. Getting?
Mm-hmm.
Now the quick,
I think we should just end class here.
that's all. Your type?
Yes.
Okay. I actually we have somewhere we need to conclude because that factors affecting the ionization energy. Actually, this is the point. Yes, you didn't ask me this question because the actual point is what are those factors which affect the ionization energy? That's what we need to discuss there. Like atomic radius is there, a nuclear charge is there, electron shielding is there. So these are the factors which affect the ionization energy. Based on that, it is decided like how much energy is required to remove any of the electrons from the outermost shell. So the amount of energy is decided based on atomic radius, nuclear charge, electron shielding, or the shielding effect. As you are saying, like we should conclude this here. So in our next class, hopefully on Monday. So in next week, we'll continue this same topic from here, right?
Thank you.
So then we'll talk about the trends of the first ionization energy and down the group and across the period. Actual topic is you should understand what is the trend of it on the periods and the groups and why. The question is why. We'll talk about that. Okay.
Thank you.
Okay, Filza, let's conclude this for today. Take care of yourself. Bye bye. See you next week.